In this video, we're going to do product rule part 2, which is going to combine some other items with our product rule. In our first example, if we look at the first function, f, we can simplify that to y equals x cubed minus 3. The process for that, one way to do that would be to simply divide both terms by x, or we could think of factoring out an x and then canceling out the x. Either way that works. So I'm going to do that first. Now I've got my first function f, my second function g. Remember that our product rule is f times g prime plus g times f prime. So dy dx is equal to our first function is x cubed minus 3 multiplied by the derivative of our second function, 6x minus 2, plus our second function, 3x squared minus 2x, times the derivative of our first function, 3x squared. In a free response question, it would be fine to leave it like this. It's possible on a multiple choice question that they might FOIL this and distribute that combined like terms. In our second example, this time our first function doesn't reduce, so we're going to have to use probably quotient rule. And here's our second function. So we have f prime of x is equal to first function 5 over 2x minus 3 times the derivative of our second function 12x minus 1 plus our second function 6x squared minus x multiply. Now we're going to do the derivative of the first function. Now remember, quotient rule, we square the bottom and then we do bottom times derivative of the top minus the top times the derivative of the bottom. So if we square the bottom, 2x minus 3 squared, we have bottom, derivative of the top would be 0, minus the top times the derivative of the bottom, 2x minus 3 would be 2. We are definitely going to want to simplify the numerator in this back part. This first part is going to go to 0, leaving a negative 10 on top. Over here then, if we do a little bit of simplifying, we could distribute the 5 here and get 60x minus 5 over 2x minus 3 plus, and then I would probably do something like negative 10, 6x squared minus x over 2x minus 3 squared. It is possible in a multiple choice question that they might make a common denominator here, so watch out for that. In our third example, we have a similar situation, only this time we have quotient rule in our second function. So again, here's f, here's g. When we take the derivative of g, we're going to want to do quotient rule. So we have y prime is equal to first function 5x to the fourth minus 3x squared times the derivative of the second. Again, that's going to be quotient rule. We're going to want to square the bottom first. Then we have bottom times the derivative of the top, which is 2, minus the top, 2x plus 1, times the derivative of the bottom, which is 3, plus our second function, 2x plus 1, over 3x minus 4, times the derivative of our first function, which would be 20x cubed minus 6x. I certainly would simplify the numerator over here. We get a 6x minus 8 minus a 6x minus 3. Remember, you're not only distributing the 3, but you're also distributing the negative. Our 6x's would cross out, leaving us with a negative 11 in the numerator. So I would go y prime is equal to negative 11, 5x to the 4th minus 3x squared over 3x minus 4 squared plus, and I would probably just leave the second one alone unless it was multiple choice and they clearly did something different. So my final answer for a free response would look something like that.